Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna.
And I'm Avery. We're coming to you on Friday, February 6, 2026. And today's show is packed with some truly incredible stories from across the cosmos.
We've got everything from lunar smartphones to daytime visible comets. Let's dive into today's headlines. We're looking at NASA's new policy that lets astronauts bring their phones to the moon, a newly discovered comet that might become visible in broad daylight, the best viewing opportunity for Mercury all year, China's ambitious plans for space-based data centers, new theories about what really powers the Milky Way's core, and a star-shredding black hole with an absolutely unforgettable nickname.
That nickname is pure gold, Anna. But first, let's talk about something that might seem mundane, but is actually pretty revolutionary for space exploration.
Avery, I have to admit, when I first saw this story, my first thought was, wait, they couldn't do that before?
Right? It seems so obvious in 2026. But here's the thing. Getting any new technology approved for spaceflight is incredibly difficult. Everything has to be tested to make sure it won't interfere with critical systems or cause problems in the extreme environment of space.
And NASA just announced that starting with the Crew 12 mission to the International Space Station next week, and more importantly, with the highly anticipated Artemis II lunar flyby mission in March, astronauts will be allowed to bring their smartphones.
This is actually a pretty big deal from a documentation perspective. NASA Administrator Jared Isaacman wrote on social media that they're giving crews the tools to capture special moments for their families and share inspiring images and video with the world.
The timing is perfect, too. Until now, the newest cameras approved for these missions were decade-old Nikon DSLRs and GoPros. Those are great cameras, but there's something more spontaneous and accessible about using a smartphone.
Absolutely. Think about it. With iPhones and Android devices at hand, astronauts can be much more spontaneous with image and video gathering. We might see more behind-the-scenes moments, more real-time documentation of their experiences.
I am already imagining the TikToks from zero gravity, though I have to wonder if that's something NASA is prepared for.
Well, Isaacman did mention that what's equally important is that they challenged long-standing processes and qualified modern hardware for spaceflight on an expedited timeline. That operational urgency, he says, will serve NASA well as they pursue high-value science and research.
Now, I should mention, this isn't technically the first time smartphones have gone to space. SpaceX allowed them for their private astronaut missions. But this is the first time NASA is officially approving them for their own crewed flights.
And for Artemis II, this is huge. We're talking about the first time humans will orbit the moon since the Apollo era. Having modern smartphones to document that historic journey, that's going to give us perspectives we've never had before.
Ultra-wide-angle selfies with the moon in the background. I'm here for it. Though I do hope Mission Control sets up some kind of social media guidelines first.
No doubt. All right, from lunar smartphones to cosmic visitors, let's talk about something that's got the astronomy community really excited.
Avery, this is the kind of story that makes you want to mark your calendar. A newly discovered comet has the potential to become one of the brightest astronomical events of the year.
Comet C/2026A1, nicknamed MAPS after the four astronomers who discovered it, Maury, Attard, Parrot, and Signoret, was spotted on January 13th using a remotely operated telescope in Chile's Atacama Desert.
And what makes this discovery so exciting is that it's a member of the Kreutz sun-grazing comet family. These are comets that pass extremely close to the sun, and historically they've been responsible for some of the most spectacular celestial displays ever witnessed.
We're talking about comets that in the past became bright enough to be seen in broad daylight. The Great Comet of 1882 was reportedly 100 times brighter than the full moon, and the Great Comet of 1965, Ikeya-Seki, was easily visible with the naked eye during the day.
Now, here's the crucial detail. All Kreutz sungrazers are believed to be fragments of a much larger comet that broke apart hundreds or even thousands of years ago. Each time one of these fragments makes its close pass by the sun, there's a chance it could fragment further or even completely disintegrate.
Right, so there's a big if here. Comet MAPS will pass within just 120,000 kilometers of the sun's surface in early April 2026. That's incredibly close. If it survives that encounter, it could become a spectacular sight.
What's particularly promising is that MAPS was discovered much farther from the sun than any previously discovered sungrazer. It was spotted at about 308 million kilometers out. The previous record holder for farthest discovery was Comet Ikiyaseki, which turned out to be the brightest comet of the 20th century.
That said, technology has advanced significantly since 1965, so we're better at detecting fainter objects earlier. That means MAPS probably isn't as large as Ikiyaseki, so it's unlikely to be quite as bright.
But the fact that we caught it so early is still a good sign. It suggests MAPS is either a reasonably large fragment or it's currently an outburst. Recent observations show it steadily brightening, which points toward it being a larger fragment rather than already falling apart.
So what can skywatchers expect? Well, the best viewing will be in early April as the comet approaches the sun. If it survives its close pass, it could become visible to the naked eye, possibly even during daylight hours as it swings closest to the sun.
Observers in the southern hemisphere will have better viewing opportunities, with the comet appearing higher in the sky during morning twilight. Northern hemisphere observers will have a more challenging view, with the comet staying very close to the sun and low on the horizon.
I love that the astronomy community is already tempering expectations while still allowing for optimism. This could be amazing, or it could fizzle out. That's the unpredictable nature of comets.
And that unpredictability is part of what makes them so exciting. We'll definitely be keeping our eyes on Comet MAPS as April approaches.
Speaking of things to watch in the sky, there's another elusive celestial object that's putting on its best show right now.
You know, Avery, Mercury gets a bad reputation as the elusive planet, but I think that's a bit unfair.
I completely agree. Most astronomy books make it sound like Mercury is almost impossible to see. But the truth is, you just need to know when and where to look.
Exactly. And right now, we're entering the best evening viewing window for Mercury in all of 2026 for observers in the northern hemisphere.
Observers. Mercury began its best evening apparition of the year today, February 6. Even though it was only 12 degrees from the sun initially, it was shining at a bright minus 1.1. Nearly as bright as Sirius, the brightest star in the night sky.
What's great is that on each of the next 13 evenings, Mercury gets progressively higher in the sky and sets a bit later. By February 19th, it reaches what's called greatest elongation, its maximum angular separation from the sun at 18 degrees.
And here's what makes this appearance so special for mid-northern latitude observers. Almost all of that separation is vertical. Mercury will stand nearly 17 degrees above the horizon at sunset, and it won't set until after astronomical twilight ends.
So we're talking about being able to see Mercury in a truly dark night sky, more than an hour and a half after sunset, shining at magnitude minus 0.4. That's brighter than the star Arcturus.
Now, there's a really nice celestial alignment coming up on February 18th. A slender, waxing crescent moon, only about 2% illuminated, will appear very close to Mercury. The moon will be this beautiful smile in the western sky, with Mercury hovering right above it like a brilliant star.
And here's something special. If you live in Texas, Arkansas, Louisiana, Mississippi, Alabama, Georgia, or Florida, you might actually see the moon pass directly in front of Mercury around 7:37 p.m. Eastern Time and 7:30 p.m. Central Time.
That's called an occultation, and it's quite rare. Even if you're not in those states, the close pairing of the crescent moon and bright Mercury will make for a stunning view about 45 minutes after sunset.
Now, after its peak on February 19th, Mercury fades rapidly. Remember we talked about how Mercury shows phases like the moon? Well, at the beginning of February, Mercury's disk was 97% illuminated. By the time it reaches greatest elongation, it's only 50% illuminated, like a half moon.
And in the following days, that rapidly decreasing phase results in a dramatic loss in brightness. By February 24th, it'll have faded from magnitude minus 0.4 to magnitude plus 0.6, losing more than a full magnitude in brightness.
By February 26th, it'll be down to magnitude plus 1.3, just slightly brighter than the star Regulus and appearing as a slender crescent, only 17% illuminated. That's probably going to be the last good chance to spot it before it disappears into the sunset glow.
So the message is clear. If you want to see Mercury at its best, don't wait. The next 2 weeks offer the best viewing opportunity of the entire year. Find a clear western horizon, look about 45 minutes after sunset, and you'll be rewarded with a bright star that's actually our solar system's innermost planet.
And honestly, once you see it, you'll wonder why people ever called it elusive. All right, shifting gears now to some developments in space technology and infrastructure. The race to build data centers in space is heating up, and China just announced they're joining the competition in a big way.
The state-owned China Aerospace Science and Technology Corporation has announced that space-based data centers will be part of their new 5-year plan for expanding China's presence in space.
This is part of a larger initiative that also includes asteroid mining, space debris monitoring, and even space tourism. But the data center component is particularly interesting because it puts China in direct competition with several U.S. companies already working on this concept.
According to the China Global Television Network, the plan will target an integrated space system architecture combining cloud, edge, and terminal technologies. The goal is to enable computing power, storage, and transmission capabilities from space.
Now, why are so many countries and companies suddenly interested in putting data centers in orbit? Well, it comes down to resources. Data centers, especially those powering AI systems, require enormous amounts of energy and real estate.
And both of those are becoming more expensive and limited on Earth. In space, solar power is abundant and reliable. The sun is always shining. Plus, there's no shortage of real estate in orbit.
Several U.S. companies are already working on this. SpaceX plans to launch space-based data centers, initially using modified Starlink satellites. Elon Musk's long-term plans even include building AI satellite factories on the moon that would launch satellites via railguns.
That's very Elon. Meanwhile, Houston-based Axiom Space already launched the first components for its orbiting data center last year, and Google is looking into launching data centers to support its own AI infrastructure.
The concept was even discussed at the World Economic Forum in Davos last month. A panel including European Space Agency Director General Joseph Ashbacher talked about ensuring that fast-moving technological developments, like internet infrastructure, are properly protected.
There is one significant concern that was raised, though. With so many satellites and data centers being planned for orbit, we're looking at a dramatic increase in the number of objects in space. That raises questions about orbital debris, satellite collisions, and the long-term sustainability of the space environment.
Right. We already have issues with space debris. Adding thousands more satellites for data centers could exacerbate that problem. It's going to require careful planning and international cooperation to make sure we don't create an unsustainable situation in orbit.
The next 5 years are going to be really interesting as we see how this unfolds. Will space-based data centers become the norm, or will we find that the challenges outweigh the benefits? Time will tell.
From the future of computing to the very heart of our galaxy, our next story challenges something we thought we knew for certain. Avery, this story is fascinating because it challenges one of the fundamental assumptions about our galaxy.
For decades, the astronomical community has accepted that there's a supermassive black hole called Sagittarius A star at the center of our Milky Way. This black hole, with a mass of about 4 million suns, was thought to govern the orbits of nearby stars and shape the gravitational environment of our galactic core.
But now, a new study published in monthly notices of the Royal Astronomical Society is proposing something radical. What if it's not a black hole at all? What if it's actually an enormous, dense core of dark matter?
This is a pretty bold claim. The research was conducted by an international team from Argentina, Italy, and other institutions. They're suggesting that what we've been calling a supermassive black hole could actually be an exotic structure composed of fermionic dark matter.
Let me explain what that means. Fermionic dark matter is composed of light particles called fermions that follow the Pauli exclusion principle. This type of dark matter could form a highly dense but non-singular structure. In other words, incredibly compact, but not technically a black hole.
What's clever about this model is that it proposes a dual-component system. There would be a dense inner core at the galactic center, but it would transition smoothly into an extended, diffuse halo that envelops the entire galaxy.
And this is where it gets really interesting. This same dark matter structure could explain both the violent orbits of stars very close to the galactic center and the gentle rotation of stars in the outer regions of the galaxy, all without needing a black hole.
The team looked at the S stars. These are stars that orbit the galactic center at incredible speeds, up to thousands of kilometers per second. The traditional explanation is that they're orbiting a supermassive black hole.
But the fermionic dark matter model can also explain these orbits. The dense core would be compact and massive enough to create the same gravitational pull that we've been attributing to a black hole.
Now, here's a crucial point. In 2022, the Event Horizon Telescope captured the first image of what we've been calling the shadow of Sagittarius A star. You'd think that would prove it's a black hole, right?
You'd think, but the researchers point out that the dense dark matter core can also mimic this shadow. It bends light with such intense force that it creates a central darkness surrounded by a bright ring, the same visual signature we'd expect from a black hole.
Lead author Valentina Crespi noted that their model explains the star orbits, the galaxy's rotation, and it's consistent with that famous black hole shadow image.
The team's statistical analysis shows that with current data, we can't yet decisively distinguish between the traditional black hole scenario and the fermionic dark matter one. But what makes the dark matter model attractive is that it provides a unified framework.
Instead of having the black hole as one thing and dark matter as something separate, this model suggests they could be two manifestations of the same continuous substance.
Co-author Dr. Carlos Arguelles made an important point. This is the first time a dark matter model has managed to reconcile such vastly different scales. They can explain everything from the central star orbits to the galaxy's overall rotation curve using the same dark matter structure.
So what's next? Well, the team says that more precise observations will be crucial. Instruments like the gravity interferometer on Chile's Very Large Telescope could help distinguish between the two scenarios.
They're also looking for the unique signature of photon rings, a key feature of black holes that would be absent in the dark matter core scenario. If future observations don't find these photon rings, that would be strong evidence for the dark matter model.
This is such a great example of how science works. We have this well-established theory about Sagittarius A star being a black hole, and it might still be. But it's important that scientists are willing to challenge these assumptions and explore alternative explanations.
Absolutely. And regardless of which model turns out to be correct, we're learning more about dark matter, black holes, and the fundamental nature of what sits at the heart of our galaxy. It's exciting stuff.
And speaking of black holes, our final story today features one with an absolutely delightful name that's doing something truly unprecedented.
Okay, Avery, I have to start by saying Jetty McJetface's might be the best astronomical object name I've ever heard.
It's amazing, right? University of Oregon astrophysicist Dr. Yvette Kendis coined the nickname as a reference to Bodie McBoatface, that British research vessel that became internet famous when a public poll chose its name.
But the name might be playful. The phenomenon is dead serious. We're talking about one of the most energetic and brightest events ever detected in the universe.
Let's back up and explain what's happening here. In 2018, astronomers detected what's called a tidal disruption event. That's when a star gets too close to a black hole and gets torn apart by its immense gravitational forces.
The technical term for what happens to the star is spaghettification. The star literally gets stretched out like spaghetti by the extreme gravitational gradient.
Now, tidal disruption events aren't uncommon. Astronomers have documented plenty of cases where a star gets shredded without actually crossing the event horizon, the point of no return. But what makes this particular event, officially designated AT2018HYZ, so unusual is what happened after the star was destroyed.
For a few years, nothing much happened. Then, in 2022, Dr. Kendis noticed something strange. The black hole was suddenly emitting a huge amount of energy in radio waves, even though the star had been destroyed years earlier.
That piqued her curiosity, and she and her team started monitoring it closely. What they found is absolutely remarkable. The radio emissions have continued to increase exponentially. The black hole is now 50 times brighter in radio waves than it was when they first detected it in 2019.
To put that energy output in perspective, the researchers say it's at least 1 trillion times more powerful than the fictional Death Star from Star Wars. Some estimates put it closer to 100 trillion times more powerful.
Dr. Kendis said, "This is really unusual. I'd be hard-pressed to think of anything rising like this over such a long period of time."
So what's creating all this energy? Well, the black hole is producing what's called a relativistic jet, a stream of charged particles moving at nearly the speed of light, all shooting out in one direction.
The leading theory is that after the star was shredded, it took some time for that stellar material to form an accretion disk around the black hole. Once that disk formed, magnetic fields began channeling some of that material away from the black hole as this incredibly powerful jet.
And here's the crazy part. The team has collected enough data now to predict that the jet will keep increasing in brightness before peaking sometime in 2027.
The energy output is comparable to gamma ray bursts, which are generally considered among the most energetic events in the universe. But what makes Jetty McJetface special is that it's been building for years, rather than being a brief flash.
Dr. Kendis made an interesting point about why this might be the first time we're seeing something like this. She noted that securing time on international telescopes is extremely competitive. If you observe an explosion, why would you expect there to be something years after it happened?
Right, so there could be other black holes exhibiting similar behavior, but astronomers haven't been looking for long-term effects from tidal disruption events because they had no reason to expect them.
Now Dr. Kendis is on the hunt for other examples. She wants to know if Jetty McJetface is truly unique, or if this is actually a common phenomenon that we've just been missing.
The good news for Earth is that we're in no danger from this particular cosmic event. Jetty McJetface is far enough away that its incredible energy output poses no threat to us. We just get to observe one of the universe's most spectacular shows from a safe distance.
It's discoveries like this that remind us how much we still have to learn about the universe. Black holes continue to surprise us, even after decades of study.
Absolutely. And I love that Dr. Kendis gave it such a memorable name. Jetty McJetface is going to be in astronomy textbooks for years to come.
And that wraps up another incredible day of space and astronomy news. From smartphones going to the moon to star-shredding black holes with unforgettable nicknames. It's been quite a journey.
Don't forget to mark your calendars for Mercury viewing over the next 2 weeks, and keep an eye on the sky in April for what could be a spectacular daytime comet.
Thanks for joining us on Astronomy Daily. I'm Anna.
And I'm Avery. Keep looking up, and we'll see you next time.
Clear skies, everyone.
Astronomy Daily.